All right, our next lesson is a lesson on what we call reference angles. Actually, a very simple definition of a reference angle is the measure to the x-axis, the shortest measure to the x-axis. And that could be in degrees or radians. Short is positive acute, acute's less than 90 angle, and radians are degrees from the x-axis. So if you can just think of this way, the distance to the x-axis. That's all we need to know. But before we get to that, it helps if we know how to draw an angle. So suppose we had an angle 7 pi over 8. And I just want to know where this is. What quadrant is that in? Well, here's a really simple way to do that. Take the denominator in the radian. We'll do some degree problems in a second. And start here. This is 0 degrees or 0 radians, and this is in radians, so I'll deal with radians. And I put the denominator on the bottom, 0 pi over 8. On the other side, I put the number on the top and the bottom because 8 pi over 8 is just pi. And if I had to go like halfway or down here, I'll show you how to do that. Just take half of those, so this would be 4 pi over 8. Between 8 and if you double that, that's 16 pi over 8 because that's 2 pi. Between 8 and 16 is 12 pi over 8. That still reduces to 3 pi over 2, which is exactly where it is. So whereas 7 pi over 8 is between 8 pi and 4 pi, so a little closer to 8, but all we're looking for is what quadrant is this in, and that's quadrant 2. All right, another example, 13 pi over 7. All right, so I take that denominator, and I put, first on this side, 0 pi over 7, and then I take that same denominator and put it on the top, 7 pi over 7, because that is pi. Double that would be 14 pi over 7, which is 2 pi. So in between 0 and 7 is 3.5, so that would be 3 pi over 7. And between 14 and 7 would be 10.5 pi over 7. All right, so where's 13 pi? It's closer to the 14, so that would be quadrant 4. Okay, but I can also do this with negative angles. And I'll deal with radian first. Let's say we had negative 8 pi over 5. Where is that? Now remember, positive we go in a counterclockwise direction. Negative we go in the clockwise direction. So this is negative 0 pi over 5. This is negative 5 pi over 5. Double that, this would be negative 10 pi over 5. So this one up here, because we're going in this direction, between negative 5 and negative 10 would be negative 7.5 pi over 5. So negative 8 pi would be over here in quadrant 1. Right, so that's how you deal with a negative, go in the counterclockwise direction. I was just asking for the quadrant, but suppose I gave you something like this. And it didn't have a degree, and it didn't have a radian. I know it's a radian because it doesn't have a degree. Now, how do I do that? Well, very simply. We're dealing with radians, and I know this is pi, so this would be 3.14. Pi is 3.14. So this is 0. If you double that, it's 6.28. So what's between 0 and 3.14? 1.57. That's just half of 3.14, which is every 90 degrees is 1.57. So if I add 1.57 onto 3.14, I get 4.71. So where is 5 radians? 5 radians would be right here, which is quadrant 3. And that also works when we deal with negative numbers like that, negative 4.3. We're dealing again with just radians. There's no degree symbol there, so this is radians, but now we're going in this direction, the negative direction. So this is negative 0, no such thing, but I'm going to put it there. Negative 3.14, this is negative 1.57. This is negative 4.71. So negative 4.3 would be over here, which is in quadrant 2. Got a little easier because our brains are wired for degrees. We've been working with them all through geometry. Radians is brand new. So how do you do 231 degrees? Well, we're positive now, so we're going in this direction. This would be positive 180. These are all multiples of 90. That's 270. And this is 0 or 360. So 231 is over here, which is in quadrant 3. Right, so that's how we determine a quadrant. But now, how do you find that reference angle? Okay, a reference angle, again, is just the distance to the x-axis. So let's start off with 5 pi over 4. How far away from the x-axis is this? So I want to draw this first. So we draw our angle, and I'm going to do it the same way I did number 1. This is 4 pi over 4. This is 0 pi over 4, or doubled. The 4 would be 8 pi over 4, because 8 pi over 4 is still 2. So half of 0 and 4 is 2 pi over 4. And then half of 8 and 4 would be 6 pi over 4. If you reduce that, you get 3 pi over 2 is exactly what it is. So where is 5 pi over 4? Now I want to draw the angle, and I want the reference angle. Again, the reference, how far is this from the x-axis, the shortest distance. So 5 pi over 4 is right here. But that's not drawing the angle. To draw the angle, to show it's positive, I go in the counterclockwise direction, and I put the arrow. If you don't have those, that's incorrect. So what is the reference angle? So what I want to know is how far is it from here to here? Well, if I asked you how far 7 was from 3 on the number line, you would say it's 4. How'd you get that? You just subtract them. So I'm just going to subtract them, and I'm always going to subtract the biggest one, or the smallest from the biggest, because it's always positive and it's always acute. So it'd be pi over 4 is my reference angle. All right, let's try another one. Let's say we had 12 pi over 5, and then we'll do a -1. And then just a degree problem. All right, so start the same way. I'm going to start this off with 0 pi over 5. And then this would be 5 pi over 5. Double the bottom. This would be 10 pi over 5. You'll see that I haven't gone far enough. So this one then would be 15 pi over 5, because that's 3 pi. All right, but where is 12? Well, in between 10 and 15 is 12.5 pi over 5. So 12 would be right about here, but going from here to here is incorrect. I got to go all the way around, and I have to show that. So there is 12 pi over 5. So that shows me the angle. Drawing this arrow and all the way around. Now, what is the reference angle? If you can just remember, the reference angle is how far away this is from the x-axis. Now, because I went all the way around plus, I'm going to use this one right here. It's always largest minus smallest to give me that positive value. So that would be 3 pi over 5. That's what we call the reference angle, and you'll see the importance of that in another lesson that's coming up, not today. And then let's say we had a negative, let's say 7 pi over 3. All right, so start off with 0. I'm going to put negative, even though there's no such thing as -0. 0 pi over 3, -3 pi over 3. Remember, negative, we're going in that direction. So double that, this would be -6 pi over 3. So notice going all the way around one time isn't enough. This would be -9 pi over 3. That's too far. So what's in between 6 and 9? negative 7.5 pi over 3. So negative 7 pi over 3 is right here, but I have to go all the way around plus some extra. So that is in quadrant 4. That's not what I was asking for. Now, how far away is this from the x-axis? Okay. Well, notice I already went past. I'm looking at these two right here. It's always, oh, I'm sorry, I'm not looking at that one. It's negative 7 pi over 3 is what I'm looking for, because it's this angle here. Not this one. It's never the distance to the y. So and you can think of these just take the absolute value, take the biggest one minus the smallest one, the absolute value, because that's what distance is anyway. And this would be pi over 3. How far away is that angle from the x-axis? Pi over 3. All right, let me do one more in a degree. Let's say you had 245 degrees. Okay, same thing. I'm going to draw this picture and see where is this. Well, I got to draw the angle anyway. That's what the directions asked me to do. These are just multiples of 90. So it's easy to see that 245 is over here. I didn't go all the way around, but it is positive, so I need to show the positive direction. And my reference angle, so this is 245. My reference angle is just how far away that is to the x-axis. Not over here, that's not the shortest one. This one's the shortest one. So, biggest number minus smallest number, and that would equal 65 degrees. So my reference angle, 65 degrees. Again, that is very important, and I'll show you that in a different lesson. That's on reference angles. Shout out to my 5th period again, and 7th, and those 3 people in 2nd period. Thank you so much for showing up every day. Have a wonderful day. Bye.